Okay, let's continue with some stylized relationships in economics, and let's talk next about production. So before we take a look at the specific function that you see here, when economists talk about production, what they basically mean is that we convert a certain input factor into output. So here, what you see is a production function, and you see L. So the L simply stands for labor. That's our input. So the way economists think about production is that we have some input, and in this case it is labor. And we convert that input into output, and let's call our output X. Okay, so now a production function is typically displayed as an S-shaped production function. So if you draw an S, it looks a little bit like this maybe. So, and the idea is to say, if we have more and more labor available, those workers, they can start specializing, and then output initially grows faster than the input. Just think about it. Let's say you have a kitchen, that's your capital, and you stand there alone and you have to prepare a meal by yourself. Well, obviously, if somebody helps you, you can start specializing, and output will grow much faster than the labor input. And if you have maybe 2 people in the kitchen, you can specialize more, and if you have 3, it's even better. But then there will come a point when you start standing on each other's feet, and output grows at the lower and lower rate. So now, if we think again of the slope at each point, you see that initially the slope becomes steeper and steeper and steeper, and then it flattens out again. So that means that the marginal output is initially very low, gets up, and then flattens out again. So if we assume that the typical production function follows an S-shaped relationship, then the marginal output function of input, which is labor, and here the marginal output, I just called it now MO, then the marginal output function looks something like this. Maybe here's the maximum, and then it levels out again. So it should be like an inverse U. So again, we have here an example, and what we do is we'll just draw it in Excel quickly. And again, this function here might be the result of an empirical estimate. Maybe we have observed a certain production function where we look at output as a function of labor, and this is what we got. So, but now let's see what it looks like in if we do that in Excel. So now our input, what will be displayed on the x-axis, that is L. And in this time, let's keep it simpler because we have workers, so we can split them easily. So let's do it 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so what is our production function? Let's quickly copy this. Okay. So I will delete that later again. Okay, so X output is equal to, so this is negative 0.05 times L, negative 0.05 times L plus 0.75 times L squared, and I just realized on the first L I forgot the cubed. And then we are here the third term plus 0.2 times L plus 3. Okay, so now I can delete this again. I can okay, why can't I see here? Let's copy this down quickly. Okay, it looks like that there was a formatting thing. Well, there's obviously a 0 in there, but why can't we see it? Oh. Okay, so I don't know what happened here, but there was like a blank cell, but now it looks correct. So, okay, so we have your labor input, a little bit bigger actually, and this is X, our output. And so that is negative 0.05 L cubed plus 0.75 L squared plus 0.2 times L plus 3. So that is correct. Okay, so let's draw it. Insert, recommended charts. And you see we get now a nice S-shaped formula, graph. And yeah. Okay, so now if we also want to draw the marginal output, MO, so then we have to take the derivative of this equation here. So the first derivative of the output function, that will be the marginal output function, that will give us the slope at each point. So let's quickly do that. So the marginal output is equal to, so the 3 in this term goes in front. So we have 3 times negative 0.05. So then if we do the math, it will be negative 0.15 L, and then we have to subtract here the negative 1, so we get squared. Plus, so the next term is 2, goes in front, 2 times 0.75, that's 1.5. Then L, so, but I have to subtract from the 2, again, the 1. So there's a 1, so I can omit that, plus, okay, there is basically an invisible 1, so 1 goes in front, so that stays 0.2, but then L minus 1, L raised to the 0, that is just 1, so we are left with plus 0.2, and the 3, there is no L, so that disappears. Okay, so now let's add this formula to Excel. and we said this is equal to a negative, equals negative 0.15 times L squared plus 1.5 times L, and then what was it, plus 0.2. Okay, let's double check again. Yeah, that's correct. Negative 0.15 L squared plus 1.5 L plus 0.2. Negative 0.5 L squared plus 1.5 L plus 0.2. And by clicking again in that little square, we can copy it down. Okay, so now what does the marginal look like? We said it should look like an inverse U. So insert, recommended charts, and you see here we get the, okay, and you can see here at 5, around 5, the slope is the highest. That means the marginal output is the highest, and that is reflected here by that value 4. That means the slope at this point is roughly 4. That means if at the point of 5 you already have 5 labors and you have like a very small increase of labor, then the output will go up by 4 at this point. Okay, so a typical production function is S-shaped, and a typical marginal output function is now inversely U-shaped. Okay, so in the next one, then let's talk about a typical cost function.